Hello, my name is Yuhao Zhang. My paper review article is Human Factors Engineering Approaches to Patient Identification Armband Design. First, I'm going to introduce what's patient identification armband design. Patient identification armband design is used for patient identification, which includes direct verification and barcode scanning. In another word, the armband should be easy for nurses to verify patients' identity by eyes, and it can also be verified by scanning. Nowadays, the major issue with the armband design is information layout. With patient armband, it can greatly help reduce the chances of dangerous workarounds caused by identification errors. And in this article, a human factor related usability testing is also detailedly analyzed. Let's talk about the background of this armband design research. There were two groups doing the patient armband design separately in two independent healthcare systems. Each has 12 hospitals. During the research, different human factors approaches were utilized by different design teams. The ideal result is to have a single, system-wide standardized armband design in each group. Previous studies have identified several potential sources of error with armband use, such as the omission of key information or display of unreadable information. Poor design, such as optimal barcode orientation, has been linked to medication errors. Optimizing barcode width and layout, in addition to implementing process changes and specific staff training, has been shown to reduce patient identification errors. So, the two major goals for this design research are readability and the armband can be scanned quickly and accurately during daily care process. The inability to successfully scan barcodes frustrates users, reduces efficiency, and can delay the administration of essential medications to patients. However, enhancing barcode scanning might actually decrease human readability, such as when barcodes take up so much space on the armband that font is too small to be easily read by staff. So it's not an easy job to accomplish these two goals. In Site 1, the design group did three activities. First, they have compared different armband layouts and data elements used at facilities to identify common elements and effects. Secondly, they have interviewed and observed different users' interactions with the off-shelf patient armbands to determine which data elements on these armbands were actually used. Finally, they have reviewed the literature and the national standards to determine the core data elements to comply with organizations like NPSGS. During their prototype process, you can see there's a huge difference between the old ones and the new armband. Before the prototype, there were so many elements on the armband. For example, the admitting physician's name was included at one facility. Another one included variations in locations. These are reduced the readability of the armband. The new design only has the patient's name and date of birth. By placing them at the top of the armband and formatting them to promote key information retrieval. Besides, you can see the barcode was given a prominent, easy to scan location and made as large as possible. Then, the design group did a usability test. The simulation-based usability test was conducted to compare a design in use at three facilities with the ideal prototype. The test used three criteria: scanning tasks, readability rating, and overall interview with all the test subjects. The participants were 10 nurses, 9 females and 1 male. Their background was ideal for evaluating the new patient armband designs, as they were well versed in the needs, workflows, and common issues faced by staff with BCMA. They used three scanners to set the scanning test: a BCMA scanner, a blood glucose scanner, and a laboratory scanner. Then, the participants were asked to rate the following features, like the usability and the readability of the armbands, on a Likert scale. Finally, all the participants were then asked the four interview questions: which armband they preferred, what they liked best and least about their chosen armband, and what additional data elements should be included. The test result shows that a great improvement has been made by the new design. You can see in the table here, fewer scan attempts were required thanks to the big barcode, and significantly higher readability because of the highlight of key information. And during the interview with the test subjects, the most common participant response was that the prototype was easier to read. This test result shows that the two goals, which are scanning and readability, were successfully achieved. In Site 2, after reviewing all the off-shelf patient armband products, the design group noticed three major problems with the current design. The fonts are too small to read the patient information. They need to change the font of bigger font size to improve readability. And the patient medical record number is too long to read. They need to break it into chunks to identify these numbers. And due to too many not relevant information, there was not enough space, which made the armband look so crowded. So they need to create more spacing. With these three targets, they designed a new version. The medical record number fonts were increased from 10 to 12. The team requested a break in the 12-digit medical record number to facilitate the staff's ability to chunk the information, and they have more spacing due to a good arrangement of the patient information. The approved prototype was trialed at two hospitals within Site 2 system for 3 months. Following the trial period, an enterprise-wide meeting was held in an attempt to standardize the armband design throughout all 12 facilities. During the meeting, the armband design was further improved to reflect the needs of end users. We can see that in both design groups, human factor principles were used. They were simplified to eliminate unnecessary information not utilized for positive patient identification. Locate patient name and date of birth and any other approved unique identifiers in easy-to-find places. Use large font sizes and style. Standardize information layout and presentation to reduce potential staff confusion. Avoid utilizing all caps for displaying patient identifiers to maximize readability. And both teams met with some software limitations. For example, they couldn't utilize the entire space and leave extra margins for perforations, and they couldn't chunk a 12-digit medical record number into 4-digit strings. We learned there are some practical considerations of using human factors approaches in both teams. In Group 1, the team was given only one type and brand of armband to optimize, which limited the feasible solutions the team was able to explore. Besides, a small number of participants, only 10 participants, were available for the simulation-based usability test, at risk that the participants were not an adequate representative sample of the frontline staff population. However, to have conducted the usability test with real nurses, given the lack of infrastructure for testing of this nature within healthcare systems, is a strength, not a limitation, since all of them were above 50 years old. So the readability of the armband has been fully proved. At Site 2, the decision was made to pilot and then modify patient armbands without simulation-based usability testing. No quantitative data were collected. Instead, the team relied on staff's feedback to inform their efforts throughout the design process, such as the addition of commonly used data elements. After reviewing this research, we have some conclusions that multidisciplinary teams can be more perspectives and expertise. Structured evaluation saves cost. Simulation-based usability testing and trial use are useful to test the prototype. At the next step, they are going to research on the impact on patient safety. Thank you. That's all.